Let us see types of question answering system. First one is extractive QA. So this is mainly efficient for task where answer can be directly found within the context or within the provided text. We already know how to solve comprehension kind of questions. Like whenever a passage is given and questions are given, we'll usually try to find out the answer for the question from the paragraph. So for such type of questions, we'll be using this extractive question answering system. And it consists of three main components, that is retriever, database, and reader. So this is the architecture. First, this is a user question. So this question is fed into the retriever. And the main goal of this retriever is to return embedding corresponding to that question. So here query vector is nothing but the embedding which is generated for this question. So here, in order to generate the embedding, we can use various techniques. So usually transformer techniques like BERT are integrated into the retriever. And it is used for generating the query vector. After obtaining the query vector from question, it is used to find most similar vectors among external collection of documents. So each of the documents, they have certain chance of containing answer to the question. So now the collection of documents are processed during the training phase by being passed to the retriever, which outputs corresponding embedding to the documents. So these embeddings, they are stored in the database, which can provide effective search. So by retrieving the k most similar database vectors to the query vector, their original text representation are used to find answer by another component called reader. So what this reader does? So reader takes an initial question and for each of the k retrieved documents, it extracts the answer in the text passage and returns the probability of this answer being the correct one. So answer with the highest probability is then finally returned from the exclusive question answering system as an answer to the user. And the second one is open generative QA. So here it follows exactly the same framework as extractive QA, except that they use the generator instead of reader. So just now we saw extractive QA is using reader, whereas open generative QA uses generator instead of reader. And here the answers are generated in a free form, that is in natural language format. So this generative QA does not retrieve answers from predetermined or pre-existing text or document. So first they'll try to understand the question, and based on their understanding of the question as well as relevant knowledge, they'll generate the answers. So by seeing the similarity, there might so we may get a question of when to use extractive QA and when to use open generative architecture. Say suppose when a reader model has direct access to the text passage containing relative information, then in that case, it's better to retrieve a precise and concise answer. So whereas generative models, they usually tend to produce longer and more generic information for a given context. So in that case, so when a question is asked in an open form, but not for situations where when a short or exact answer is expected, in that case, you can go with open generative question answering system. Because these generative models, they usually provide longer and more generic information for a given context. And the last one is closed generative QA. So it does not have any access to external information and generates answers by only using the information from the question. So unlike open generative QA systems, so if you take open QA systems, they can handle wide range of questions and topics. So there is no restriction on the scope. Whereas here it is not like that. So here scope is very limited. So it can deal with only specific knowledge domain questions like medicine, sports, etc. And it can provide answers to only few type of questions. Okay. So scope is very limited and answers are extracted from small collection of data, mostly structured data like ontologies. So they can provide answers which are specialized to specific domain or knowledge base. So this is the architecture. So you can see the advantage of closed question answering system is reduced pipeline time. So we do not have to search through large collection of external documents. So it comes up with the cost of training and accuracy. So the generator should be robust enough and have a large training knowledge to be capable of generating appropriate answers. So these generators, the generators which we are using here, they do not know any information that appeared later in the data it had been trained on. So to eliminate this issue, generator can be trained again on a more recent data set. So generators usually have millions or billions of parameters. So training them is an extremely resource heavy task. So here dealing with same problem with extractive QA and open generative QA is much simpler. It is just enough to add new context data to the vector database. So most of the time, closed generative approach is used in applications with generic questions for very specific domains. Performance of closed generative models tends to degrade.